We have already dealt with finding the limit and finding it to be infinity, but so far we've basically been using our calculator to do that. So in this lesson, you'll be able to use the properties of infinite limits to find a limit without using your calculator. Okay, the properties of infinite limits, we're going to start with a certain assumption. We're going to let c and l be real numbers and f and g be functions such that the limit as x approaches c of my function f is infinity, and the limit as x approaches c of another function g is L. So one function has a limit of infinity, the other one actually has a number like 5 or 2 or something like that. So these properties will hold if that works. Right, first of all, the sum or difference formula tells us that if we have the limit of one plus the limit of another, that function will equal infinity. And although this is a property that you could actually memorize, I'm going to show you how we don't really need to memorize it. Okay, so first of all, we have to find the limit as x approaches 0 of 4 plus 4 over x squared. And again, if we were able to graph this, this would be pretty easy to get the answer for. But since we are not able to, we're going to actually use the properties of limits. If you remember from the first day that we looked at limits, we learned some properties, and one of the properties was if you have a plus sign in your problem, you can actually find the limit of each of these separately and then add them together. So I'm actually going to write this as two separate limit problems. So we're going to find the limit as x approaches 0 of 4 plus the limit as x approaches 0 of 4 over x squared. All right, in this first one, to find the limit as x approaches 0 of 4, we want to try to use direct substitution. You will notice there's no place to plug in 0 because there's no x. So basically that just means that this answer will always be 4. So the limit of that function is 4. Okay, for the next one, you'll notice if I go ahead and try to use direct substitution, if I try to plug in 0 for my x squared, I end up getting 4 over 0. And again, remember that doesn't mean we can't find the limit. That just won't work for the way to find the limit. I notice there's no canceling or anything to do, so I'm pretty much stuck. So what I'm going to rely on is my knowledge of I know what a 1 over x squared graph looks like. And I think this was in the actual like P1 that we did this, but the graph of 1 over x squared looks something like this. So the graph of 4 over x squared is going to look like that as well. So if I'm trying to find the limit as x approaches 0 of 4 over x squared, now that I have a picture, I can actually do that. If the limit as I'm coming in from the left equals infinity, the limit as I come in from the right also equals infinity. So I know that the limit of this function is actually equal to infinity. So now we have 4 plus infinity. And if you just think about this common sense wise, infinity is like a super duper huge number. If I add 4 to it, it's just going to be an even more super huge number. So it's still, my limit is going to be infinity. Adding 4 to it really is not going to make a difference in my answer. So the answer to that problem would be infinity. All right, let's look at the product rule. This time I do have some properties listed up here, but again, I'd like to kind of show you what happens. All right, if we look at this example again, find the limit as x approaches 0 of 1 over x times 5. Again, this would be an extremely easy problem to do if I was able to use my calculator. But since I'm not, again, I'm going to rely back on those property problems that we learned at the beginning of this chapter. And so since there's a time sign, I can actually find the limit of each one separately and then multiply them together. So I'm going to have the limit as x approaches 0 of 1 over x times the limit as x approaches 0 of 5. Okay, I'm going to go to the one that's easier first. If I wanted to try direct substitution on the second one, again, I can't plug in 0, but 5 just is always going to be 5. So the limit of that part is 5. All right, this next part, we always want to try direct substitution. So if I plug in 0 for my x, notice I get 1 over 0, and that doesn't mean that my function doesn't exist. My limit doesn't exist. It just means I can't find the limit that way. So again, there's no cancellation, we can't rationalize, we can't use the sign property, everything is done. So what I'm going to do in this one is rely on my knowledge that what 1 over x looks like. And again, if you went back to your chapter P, the graph of 1 over x looks like a graph that is in the first and third quadrants. And just to make this problem go correctly, instead of having it approach 0, let's just have it approach from one side, otherwise the limit wouldn't exist and we couldn't test the property. So let's, on this one, let's put a negative there. Whoop. So let's just approach 0 from the left side. So as I'm approaching 0, So for all of these, let's just do that. Okay, so as I'm approaching from the left side, you'll notice that I'm headed towards negative infinity. So that would be my limit. So now I have negative infinity times 5. So a negative times a positive will be a negative, and infinity times 5, again, that's really not going to make a difference. It's still going to be infinity, because infinity times any number is still infinity. So that would be my answer. If I changed this problem and I ask you to find the limit as x approached 0 from the right, the way that this problem would have been worked differently, if I was approaching from the right, I'd be headed up towards positive infinity. This part would still be 5. Infinity times 5 would be infinity. So that's how it would work differently. And I really can't solve this problem when it's just approaching 0 because the limit did not exist. All right, the third property is the quotient property. You'll notice if I have two limits divided by each other, it will equal 0, but I'm just going to show you how that will work. Right, the first thing that I notice is that we have this top guy up here as a function, and this one down below as a function. And again, if we had our calculator, this would be pretty easy to do, but we don't have our calculator. So since it's division, I'm going to again write it as two separate problems. I'm going to write it as the limit as x approaches 1 from the left of x squared plus 1 divided by the limit as x approaches 1 from the left, of 1 over x minus 1. Okay, for this first limit, the first thing that we want to try is direct substitution. So can I just plug 1 in? And when we do direct substitution, you can ignore the negative sign. You can just plug in 1. So if I try to do that, I'll get 1 squared plus 1, and that equals 2. So the limit up top is 2, and we can just leave that alone for now. Okay, down on the bottom again, we want to first try direct substitution. So if I try that, I'll plug in 1 over 1 minus 1. That gives me 1 over 0. That does not work. Again, it doesn't mean we can't find a limit. We just can't find it that way. So we've got to go to a new way. None of the techniques that we learned in 1.3 will apply. So again, I'm going to rely on my knowledge of what that graph looks like. All right, we know that the graph of 1 over x looks like this. Whoops, should not cross that line though. So 1 over x minus 1, keeping in mind what we know about transformations, this graph, because of the x minus 1, is just going to shift to the right one spot. So instead of the asymptote occurring at 0, it's now going to occur at 1. So let's just bump it over there. And otherwise it's going to look like the same graph. So that's what 1 over x minus 1 looks like. And now we want to approach, this says to find the limit as x approaches 1 from the left. So as I'm headed in from the left, I'm headed towards negative infinity. So that is infinity. Okay, so now what on earth is 2 divided by negative infinity? All right, if you recall, whether it's negative infinity or whether it's infinity, it's a really, 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 really big number. So if I take 2 divided by a really, really, really big number, whether it's negative or positive, I'm going to be getting really close to 0. So my limit in this case would be 0. So if I have a number over infinity or a number over negative infinity, the limit of that problem will be 0. So hopefully you can now use the properties to find limits without using your calculator.